All right, so welcome back to this quick one-way ANOVA example. So just kind of the first big takeaway, I think, was that we could write this kind of new one-way ANOVA model in the way that we wrote models before using indicator variables, and they're the same exact model. The ANOVA model is just nicer if we want to compare means, because then we don't have to like redefine a reference group all the time. You can imagine with even more groups that would get it even more painful. And so that's kind of the big benefit of doing it this way. The second kind of major thing that we haven't talked about yet that I feel like should at least get a mention is this issue of doing multiple comparisons in hypothesis testing. And so to kind of talk about that, we're going to jump all the way to the bottom of page 6 on this handout, where it has that little header for multiple comparisons. And so we're going to kind of redefine what this type 1 error is. We haven't really discussed this too much in this class, but it should be something that you're familiar with from Stat 113. And this type 1 error is rejecting the null hypothesis, or the way that we've written conclusions is like saying there is a lot of evidence for the alternative. So we reject this null hypothesis when in reality the null hypothesis is actually true. Okay, so even like when we do like one statistical test, there's kind of this chance that if we reject the null hypothesis, we say that there's strong evidence for the alternative. There's a chance that the null hypothesis is actually true and we made this wrong decision. So that's totally fine. That's just something that has to be accepted when we do statistical hypothesis testing. What the issue with this multiple comparisons is, and I was originally going to talk about this a little bit more mathematically, but I think that we could all get this intuitive idea that for these multiple comparisons, we can't just do like 30 statistical tests on one data set and then just report the ones that are significant as if they're statistically significant without really saying that we did these 30 tests and adjusting for the fact that we did 30 tests. Like imagine I like gave you an exam and it was multiple choice and you had no idea what any of the answers were, but I let you take the exam 50 times. And then I saw that in one of those 50 times you got a passing grade. And so then I was like, okay, there's evidence that whatever your name is, you know what you're doing. And so there's evidence that you know this stuff just from that one exam that was a passing grade. That doesn't really make sense. I wouldn't ever really want to do that. And so if we do more than one statistical test on the same data set, we want to make sure to adjust for that. How we would adjust for that, I'm kind of jumping around a bit again to page 8. If we're comparing different means, like in our dog example, and we're comparing like the friend group to the control group, the pet group to the control group, the pet group to the friend group, that's 3 different tests, which means I have to adjust for that. And one adjustment method is this Tukey's HSD, or Tukey's honestly significant difference, which we're not going to talk about, but just I think the important thing is just to be aware that we can't just do 100 tests on a single data set without some sort of adjustment. What could happen if we do that, I'm going to link to this article. Actually, I'll link to it in our handout for today that's called The Fluctuating Female Vote, Politics, Religion, and the Ovulatory Cycle. And so this was a published article that I'm just going to read their last sentence in their abstract, which says, overall, the ovulatory cycle not only influences women's politics, but also appears to do so differently for single women than for women in relationships. So this article found that women were more or less likely to vote conservative depending on where they were at in their ovulatory cycle, which most people, I think, would find a little bit ridiculous. One thing, not necessarily that these authors did this specifically, we'd have to know exactly what they did, but one thing that could have led to this conclusion was if they did this multiple hypothesis testing and just kept doing statistical hypothesis tests until they found something significant, and then reported the significant result. In this case, the ovulatory cycle influencing whether or not women would vote conservative. So, if you have any questions about this, definitely let me know. Again, the big takeaway is that you can't just do hypothesis testing like over and over and over again until you find something significant. If you did that, you'd have to adjust. And like I mentioned before, there would be more of this in this Stat 226 class, which is offered in the fall. But like most advanced stat classes, if you haven't registered, it's probably filled up by now. The handout today will be like super short. It's just going to be about 5 minutes, and it will just, okay, we'll see on the handout. No need to make this video longer than it is. All right, so let me know if you have any questions, and have a good one.